Okay, so I just asked you to do a few questions just to see how comfortable you guys were using pages 8 and 9 of the reference table. The reason I'm having you do this, and we talked about it yesterday, is that you have a quiz tomorrow on pages 8 and 9 of your reference table. So here's some questions that we haven't done too much with. So I already heard we needed some help on question 40. So it says the diagram to the right shows an index fossil found in the surface bedrock of some parts of New York State. In which New York State landscape region is this gastropod fossil most likely found in the surface bedrock? So we got to just start with the information they gave us. So we see this thing. To me, it looks like a little coil of dog poop, but I don't think that's what it is. It's really this guy right here, letter W on your reference table. So the question is asking you where in New York State we'd find this. But before we do that, we need to know when this guy lived in New York State. So we check out that W lived in New York State right there. Only this little circle is when W was around in New York State. That W, if we follow it over, was during the Ordovician time. So again, what I did is I found W, went over, and it's from the Ordovician. Now that tells us when, not where. But we learned, hopefully you remember this reference table, page 2, which is the bedrock of New York State. So not only does it tell you the kind of rock it is, but it tells you when. So if you find the key here, it tells you that the Ordovician, so back from where that W was from, is the diagonal lines. That's Ordovician. So there's not too many places that have those diagonal lines. I'm seeing some right here on the east coast of Lake Ontario, and some down here right where it starts to become diagonal on New York State. Again, they wanted a landscape region, so that's these guys up here. Now I'm just going to go with what they gave me. My choices were the Tug Hill Plateau. So I find the Tug Hill Plateau. There is that just to the east of Lake Ontario. So Tug Hill Plateau is right around here. So in the diagonal lines. The Regents loves that kind of stuff. I literally needed to use 3 reference tables to answer that. I did, and I teach this stuff. So it's not, I'm saying you guys can't skip using 3 reference tables to answer one question. And they love that. They love making you flip pages. Anytime that you get to a question, you're like, I just don't know where to start. Just start flipping through your reference table. Hopefully you'll find clues to get you there. So that was that one. I guess we'll go backwards on this. 39 was another one I had asked you to do. So I'd asked you to do 40, 39, and 33 on this page. So let's do 39 while we're here. The presence of which index fossil in the surface bedrock most likely indicates that a forest environment once existed in the region. Guys, what are some things that you might have expected to live in a forest? Trees. What else might you find in a forest? Plants. Maybe some birds. What wouldn't you find in a forest? Fish, shellfish, clams, anything that lived in water, so coral. So we want a fossil that may have lived in a forest. They only give you 4 choices. So there are a lot of choices down here and lots of them could have been in a forest. But out of the 4 they gave us answer A was this thing right here. And lo and behold, what is that? It's a tree. So I'm pretty sure it's that, but I am going to double check the rest of the answers. The other answer was this thing right here. That's answer B. That's a shellfish thing. So again, that's not in a forest. Another one is this, and that's actually a piece of coral. How do I know it was a coral, by the way? U is on the line labeled coral. So that's a coral. We don't find those in forests. And the last one is that B word. Where is that? This guy. Oh, that's a fish. So that's also not going to be in a forest. So that answer was that first one. I have no idea how you say that word, but that's a tree. Then I asked you to do this one. Which one lived the longest time? Brachiopods, crinoids, dinosaurs, or corals? This is where you look at these lines. So we only briefly looked at these the first day we looked at this reference table. So again, I'd like to compare this line to if this line was dogs. This is how long dogs were around. And this would be different kinds of dogs. So maybe golden retriever and a Great Dane, something like that. That's not exactly true because it'd be more like canines and wolves and coyotes, etc. But we don't need to get into the details of that. But this is just, so we want to know which one's been around the longest. They had 4 answers. Here's the brachiopods. Here's the crinoids. Maybe I lost them. They're here somewhere right there. So it's another pretty long line, but it's a little shorter. So far it's the brachiopods. Dinosaurs are here. That's a real short line, so it's not them. And then corals, again, is a nice long line, but it's not as long as the brachiopods. So in that case, it's the brachiopods. Then on the previous page, I had asked you to do 16, 20, 21, those 3. What is the name of the index fossil from the Cambrian period? So there's Cambrian. I asked for the index fossil. There's only one letter there. Letter A. By the way, do not write answer A. The answer is this thing right there. Lisiophilia. I have no idea how you say that again. So my only word of warning is to be careful when spelling this out. Hang on, I'm being careful. Careful when you write that word, because it's, first of all, a word I've never understood. And there are so many other words that could, like this one begins with an E and has a bunch of letters. That one has an E. Just all I'm saying is you don't have to spell it right, but make sure you're careful enough so that I don't think it was a different word. All right. Why were there no birds found in the Ordovician bedrock? What'd you find? That's a good way. Did anybody word it different? Here's the Ordovician. Here's earliest birds. So something along the lines as birds weren't around yet. Were not around during Ordovician. Or you could have said that birds did not get to Earth until much later. Birds did not appear on Earth until the Jurassic, however you want to word it. And then finally, what's a good index fossil for the Triassic? Triassic, index fossil, letter L, come down here. L is this guy, the Cloophysius. How'd we do? Goodish? How was your homework last night? Were there any that gave you issues? I know I gave you about 10 minutes in class to do it. Did anyone have issues after you left class? Okay. All right, then if you had no issues, I'll just go ahead and give you the answers. Let's start, I'll go kind of quick. We're going to start with earliest insects. That was late Silurian. Diverse bony fish, early Cretaceous. Earliest fish, middle Cambrian. Earliest bird, late Jurassic. Earliest reptiles, middle Mississippian, or you could have put middle Carboniferous. Humans, again, be careful when you write this word because it looks like it could be spelled wrong. And don't spell a different word. So that's Pleistocene Quaternary. Earliest trilobites is early Cambrian. I told you you could skip I. Did I tell you guys to change it to earliest? Okay, so if you did change it to earliest sharks, it would be early or middle. It was kind of in between those two, so I would have taken either one. And Devonian. Then for the next one, the uplift to the Adirondacks, I said was the early Cretaceous. You skipped C. Opening of the Atlantic Ocean, early or middle Jurassic. And Pangea breaks up in the late Triassic. Any of those that needed questions answered? All right. Then Then the next one, be careful because I screwed this one up because I did not read carefully. It says the Acanian orogeny. Make sure you actually read the Acanian and not the Alleghenian. Just because they both begin with the letter A, they're very different. So that's there. It specifically said period. And that's one thing I want to point out is when they say period, make sure your answer is coming from the period. If they say era, make sure your answer is coming from the era. Or if they say epoch, make sure you answer the epoch. So that one is Devonian. And what was that between? That was a collision between North America and Avalon. And we got all of that information right from here. Again, I circled this. This was era. So it's geological era. That's the Paleozoic. Mesozoic era lasted 185.5. Which one was the longest? That's the Paleozoic. First coral reefs, Ordovician. Yes, I spelled that wrong. Phanerozoic began 542 million years ago. Jurassic period lasted 54 years. First forest was Devonian. And who knew the answer to number 10? Were you guys able to figure that one out? What'd you guys put as an answer to number 10? Where was Western New York 362 million years ago? What'd you say? Okay, it wanted to know where North America was. What? Equator? That, okay, let me show you how to do this if you didn't know how. So it was 362. So there's 359. There's 415. So we're like a little under the 359 line. If you follow that over, you'll see that there's a globe all the way over on page 9. North America is highlighted black. I covered it up with my line, but you can see the Great Lakes. So you know we're near the Great Lakes. And I drew a line over the equator. So those Great Lakes are practically right on top of the equator. So that's what I was looking for. So where is it located? It's located on the equator. And finally, the first flowering plants, I put 100 million years, but your answer could have been anywhere between 65.5 and 146. Were there any that you had issues with? Didn't get right? Don't know why they're wrong? No? So you guys are like ready for the quiz tomorrow? Yeah. All right. Good. I'm excited. The question, there are 18 questions tomorrow. 17 of them are multiple choice. One is fill in the blanks. There's just 3 blanks you need to fill in. And every single answer will be on your reference table. You're more than welcome to use your colored copy of your reference table tomorrow for the quiz. Is there anything else you guys were stuck on or confused with on this stuff? Ready to ace it? Awesome. So then what we're going to do, we're going to continue on a little bit with what we were doing yesterday. But before we get back into practicing, let's go to the back page of your packet. It's page, is that 30? Yeah, page 30. It's the very back page of your packet. So on page 30, we have a little bit of a combination of everything we've just been looking at. So we've got the rock layers in there. So we know how to tell which one's the oldest and which one's the youngest rock layer. We have some magma that came up. You know how to tell me which is older. But the next thing that we have in here that we haven't so much talked about are fossils mixed in with the rocks. To kind of give you a good real life example of this, I have a slightly goofy PowerPoint. Here is a picture I took many years ago now. Can you guys see what this is? A wall of what? It's a snowbank. This is a snowbank. This was after the first November storm. Like, what were you guys, like 3rd grade, I think? Like a long time ago, November storm. You guys don't even know about it. because it didn't even snow out here. It just snowed closer to Buffalo and you guys got 2 or 3 days off of school and it was beautiful here. But, me and Mr. D, we were covered with like 8 feet of snow out in Buffalo. So this was after that, driving my kids to gymnastics and I see this ginormous piece of equipment. It was the biggest snowblower I have ever seen in my life. You know how snowblowers have those like tongs that rotate on the inside? I swear you could have just put my car in front of it and it would have eaten my car. It was huge. But it was pushing back the snowbanks. Our snowbanks were huge. So it was just coming along and eating the snowbank, and it left behind this. I literally slammed on my brakes. My husband and my kids thought I was insane, which you guys all know I am, but this was a new one for them. And I'm like, I have to take a picture of this because this is easier to understand because you guys have seen stuff that looks like this. What you haven't seen too much of are rock layers. So this, I think, puts all of this in, makes it a little bit easier to understand. Now, can you guys actually see it or is it just me that can't? I'm like noticing a glare and I can't. Is that better? Yeah, a little bit, okay. How, it was literally taller than my car. It's huge. It snowed, we had no lie 8 feet of snow in one weekend. It was right before Thanksgiving. It was the weekend before Thanksgiving. By Thanksgiving, it had all melted. It was horrible. But anyway, 8 feet of snow. This is probably 6 to 8 feet tall right here. Now this snowbank kind of tells a story about what was happening during this snowstorm. So what are a few things you notice about this snowbank? There's layers, and what do you notice about some of the layers versus other layers? So some are dirty and some aren't. Some are real thick, some are real skinny. Now, I think you guys know why there's dirty snow. Do you guys know why there's dirty snow? It's from the plows. The plows put down a mixture of salt and sand, and I'm sure there's some other stuff, but I'm not an expert in this field. So they put down dirty looking stuff that gets mixed in with the snow. What's with this thicker layer of white here? It's freshly fallen. Now, why weren't the plows plowing it? Why didn't it get mixed with dirt? It was literally snowing so fast that snow plows were getting stuck. They could not keep up with it. So for this section here, the plows didn't get to this area. It snowed a good couple of feet before the plows could get out again. So there was no dirt in that layer of snow. Then you can see the plows came back out, but then you can see another smaller but decent sized white chunk. That was when this area here, we all thought we were good. And then it came back again. It was like a worst case scenario. We all thought we were safe and then it blizzarded again. It's awful. And then you can see they were able to kind of keep up. So this is the road right here. Here's the road. This is the side of the road. So this snowbank can tell a story of the snowstorm. Rock layers can tell a story of the area. So remember, if we have rocks that are bigger, that have big sediments, we know it was covered by a shallow sea. Or if we have rocks that have small sediments, we know it's covered by a deeper sea. So they can both tell a story. But now here's where I'm going to make things a little, you got to use your imagination. Which snow is the oldest here, by the way? The bottom snow. Which snow is the youngest? The top. Okay, so you know that. Now, what if I found, let's pretend this wasn't one weekend. Let's pretend it was a whole winter. Now, let's say in this layer of snow, I don't know, can you guys see what that is? It's a Happy New Year's hat. It says Happy New Year's on it. And then can you see what this is? Could you guys closer see what that is? These are pink and red teddy bears with hearts. Okay. I like to think of these as index fossils. What's an index fossil? By the way, there's 3 things it has to be an index fossil. Do you remember what they are? By the way, you got to remember what they are. Index fossils. Remember? No? How about widespread geographically? Easy to recognize and live for a short time period. I think these are perfect examples of index fossils. When do you find Happy New Year's hats in the stores? New Year's, like, could you literally go to a store today and find a Happy New Year's hat? Probably not. So that means they only exist for a brief period of time. Can you go anywhere in the United States probably and find a Happy New Year's hat during New Year's time? Probably. They're widespread geographically. Is this easy to recognize? Yes, it literally says Happy New Year's on it. What would not make a good index fossil would be a hat that says Happy Homecoming Pioneer. Why would a hat that says Happy Homecoming Pioneer not make a good index fossil? It's not widespread. It's only here. So you'd only ever find pioneer hats here. So these are good index fossils. Same with the teddy bears. What do these teddy bears represent? February 14th, Valentine's Day. Again, they're easy to recognize, they're widespread, and they're only in stores for a short period of time. So these make good index fossils. So if I found this hat in the snow, when can I assume that this snow happened? Around New Year's. This snow was probably around January 1st. And if I found this teddy bear in that snow, how old is the snow around the teddy bear? Probably February 14th. So now I'm combining, so we know the absolute age of this hat, and we know the absolute age of those teddy bears, but now I can use relative time at the same time. So if I put a question mark right here, when could that snow have been from? Okay, it could be anywhere between January 1st and February 14th. Do we know exactly? No, but we do know it's in between those. What if I put an X up here? When is this snow from? After February 14th. It's newer than February 14th. And then again, the snow at the very bottom, how old might that be? Earlier than January 1st, so it could have been Christmas. So see how you can combine absolute and relative time? So now we're going to go to that page on page 30 there. And here. See if you can answer. Well, actually, let's do some of them together. Based on the fossil evidence, determine the geological period which the unconformity formed. What's an unconformity? Nope, that's an intrusion. Good try though. Unconformity, guys. That's what? That's the erosion one. So remember that is shown with the squiggly darker line, which you can see right here. And I believe it told you in the reading. Yep, XY represents an unconformity. So we want to know during which geological period could this have formed? How in the world do we know when this formed? Walk me through how to do this. What do you guys think? Olivia, what are you doing? I see you working. Looking at your reference table, what are you looking for? For the index fossils. So we know that this squiggly line happened sometime between that fossil and this fossil. And we luckily know how old each one of those fossils are. Right now, everybody go find the periods for these two fossils, that fish and that piece of coral. So I see that fish here is letter R. Letter R happened during the late Devonian. I'm just going to go ahead and label that. Late Devonian. And this piece of coral, which is letter I, happened right there, the early Devonian. So to answer the question, during which period did that unconformity happen? When could it have been? How do I answer that? What period then did that middle thing have to have happened? Thank you, Devonian. If this happened during the Devonian and that happened during the Devonian, something in between it would have also had to be during the Devonian. All right, answer 47 through 50, please. So the depositional environment means what type of environment could this thing have been deposited in? So types of environment could be a marine environment, so water like ocean or lakes, could be a forest, could be a desert, could be an Arctic, so a frozen environment. Again, you're just answering the rest of the questions there on the bottom of page 30. The one that's around the same time. All right, we only have a couple seconds left, so let me make sure you got a good understanding of this next one. The next one asks which coral index fossil, you couldn't just pick your own, whichever one you wanted. Which coral index fossil would have existed at the same time as however you pronounce that letter I? So there's letter I want a coral. So I have to find the line that's labeled coral. So one of these three, V, W, or T, was around the same time as I. That's letter V, which if you go down, letter V is the plural dictum. I don't know if that's how you say it, but that's letter V. Then it says to be an index fossil, you have to live for a relatively short geological time interval. State one other. They either need to be easy to recognize or widespread. Now, what type of environment could these fossils have been deposited in? We have a fish. We have some sort of shellfish. We have another shell and a crab. All of those things would have lived in a water environment. So you could have said water or marine or a lake. Any of those would have worked. And then how do we know that the igneous intrusion A is older than the sandstone? So here's the intrusion. Here's the sandstone. Well, how do we know it's older? What did you guys say? The intrusion's older than sandstone this time. Two good answers. Give me one. It's below A, or there's no contact metamorphism on A. You guys have a quiz tomorrow. Make sure you are ready to take that quiz.